Time for some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed, Mr. Universe at your Amherst kitchen table. And while we wanted to talk about cool things that we're seeing in outer space like dwarf planets, we, like so many other people, are forced to talk about the big, beautiful budget. But before we do, some local astronomy. Northern Lights, again last night, but only through an iPhone. So luckily my son Enzo was with me. He was like, Dad, look through my iPhone. My iPhone won't do it. His iPhone does it. So I got to see him again.
What time was that?
It was 12:15 a.m.
Oh, okay. Because I was going to complain about it. Why you didn't call me? Because last couple of times I
called you. Yeah, I didn't want to call you at 12:15 a.m.
Yeah, no, I did actually go out before going to bed with my dog, sort of like trying to take him out. And I did look up because I knew that there could be northern lights. But again, I just looked up and there were clouds and I did not go with the iPhone thing. So
yeah, here's the thing. It's lame when you have to look through your iPhone to see them. It's awesome when you see them with your naked eye because you feel like you're really experiencing them. However,
which we did last year.
Which we did.
And that was amazing.
It was amazing. But most astronomy, that's exactly what happens. You have an X-ray telescope or an infrared telescope, can't see that stuff with your eyes anyway. So why not look through an iPhone? It's all the same.
But it's still a chance for northern lights next couple of days. So
yeah, take that iPhone out there or whatever type of smartphone that has some sort of night vision on it. Sometimes it'll pop up right away.
And hopefully with your eyes, take your eyes with you.
First try your eyes and then try your phone. The reason I was up so late is because I was at my friend's weekend-long video game party. And one of the nights spent over an hour debating about the existence of aliens. So that's another moral. Everything I learned from you, I was like, give me one shred of evidence of one single-celled organism, living or dead, anywhere else from Earth, and I will believe that there's a huge government conspiracy. But until that day, where people have dedicated their entire lives to find one dead cell, I'm not going to believe it.
And now, considering that, you would say, well, NASA or NSF or the President of the United States, you can believe them. The problem is that I just read, that was the news in the New York Times. So there are all these variations to that about the next thing that I'm going to say, that President Trump is promoting the conspiracy theory that Biden
it's a clone.
Is a robot.
Yeah, clone and robot. Real Truth Social post. As far as I can tell.
So, yeah. So, I think the alien stuff is still far more believable compared to
That's true. If anybody was going to disclose a secret government program about aliens, it would be the current president.
But there are mysteries, and I wanted to bring up, I know we're not going to talk about the discovery of a dwarf planet in our solar system today.
Which did happen, though.
Which did happen, but the dwarf planet is still going to be there next time we talk about it. So I'm not too much worried about it. But I did want to mention a really fascinating object that astronomers have detected, and we have no clue about what it is. This was there is a class of objects which have been discovered in the last couple of years, and those have been discovered through radio telescopes. And so, again, this is not something that you can see with your eyes.
You put your eye on the lens of a telescope and look and say, hey, what's that?
And so these are objects that are in our own galaxy. So of course there are in other galaxies as well, but they've been detected in our galaxy, and they vary in brightness. They have pulses. Now, we have talked about many times before objects like pulsars, that you can have pulses many times a second. In fact, the most famous pulsar is the Crab pulsar. This was the leftover from a star that exploded in 1054 AD, and that it left behind a spinning neutron star. So this is the end stage of when a large star explodes. That's the end stage that's left, and it's spinning really fast. So that particular star, core of a star, neutron star, is spinning about 33 times per second.
Almost like a record.
And there are others that actually spin even much faster than that as well. I think the record is like 500 or 600 times a second. But these newly discovered sort of like these variable stars, these pulses that are coming from, are in about 44 minutes, or 20 minutes, 30 minutes. And the latest one that they discovered is the 44-minute pulse. Now, that's a little weird because we don't know what would be producing it. So that was already a mystery. These are called long period transients, so LPT. And but then Chandra X-ray telescope. So originally the radio telescopes that were used to discover it were in Australia and in South Africa, in particular the Australian one, which is called ASCAP. And but then Chandra X-ray Observatory, which as the name suggests, looks in the X-ray universe, and it detected a same pulse from one of the radio objects. And in fact, what they discovered was that the X-ray, and this is how they know actually, that the X-ray variability matches the radio waves, meaning to say it is also pulsing in the same way every 44 minutes. So basically, this object becomes active for 2 minutes every 44 minutes.
And not only active in X-ray, but active in radio waves as well.
Right. And so this is something that we have never seen before. This is the first time, and we don't know what it is. This object is about 15,000 light years away from us.
So every time that 2-minute pulse happens that we see right now, it left that, whatever it is, 15,000 years ago.
That's correct. And we also are seeing that it is changing. It has gotten dimmer in the last 6 months or so. So whatever is happening actually usually in astronomy, again, we talk about millions of years or whatever, but this is happening in a very short time frame. We have no clue what this object is. There are ideas, there are these highly magnetized, again, neutron stars called magnetars, sound like a superhero.
It sounds like Transformer or something.
That's right. But you would have other wavelengths in there as well. You would not just be producing variability in radio waves and X-rays and nothing in between. And so we don't know what it is. It may be a white dwarf, the thing highly magnetized white dwarf. Maybe it is orbiting another star, and so material falls on it and it produces this. But we have no clue. But what I wanted to really, this was a long way of coming back to a sad part.
We got to the fun, exciting science part. Now back to the big, beautiful budget.
That the NASA budget or the total budget has been released, and NASA and NSF funding is there. So Chandra X-ray Observatory, it is one of the 4 great observatories, which included Hubble Space Telescope, which revolutionized astronomy. I mean, literally. So because I was in graduate school, I was an undergraduate when it was launched, and I think I was amongst astronomers, one of the first generation of astronomy students who saw the transition happen, who saw the revolution take place, where there were these schematics that we used to have in terms of, for example, I worked on how stars form in galaxies and star formation in general, and we would have these schematics of how it might happen. And then with Hubble Space Telescope, you could actually see fine details of these nebulae, which you might have, everybody have seen these images. For example, the Pillars of Creation, for example, that's just one image. But there were so many others. And it just transformed astronomy. In the same way, there was an infrared telescope and called Spitzer Infrared Observatory, and Chandra X-ray Telescope is also one of them. Now, Hubble Space Telescope is still operational. It is still producing great results. Of course, we often talk about James Webb Space Telescope, which
Salman is wearing a James Webb Space Telescope T-shirt.
And so, so I was like, okay, I'm going to talk about this, and so I should wear astronomy with me, on me. And so James Webb Space Telescope is, of course, the next generation telescope from Hubble Space Telescope, and James Webb works in the infrared. And there was a reason why astronomers picked infrared, because they wanted to complement the kind of discoveries that have made by Hubble Space Telescope. In the same way, Chandra X-ray Observatory works in the X-rays, and it has been around since early 2000s. And it has been extremely crucial because it complements the other things, the other wavelengths, the other light that you are seeing, but this is also in space. And if the proposed budget goes through, and I should again emphasize that this is the budget that has been proposed by the White House. It hasn't been approved. It has to be approved by the Congress. If it gets approved, Chandra X-ray Observatory, which is just, it's operational, it is working, that will get canceled. But not just that. Let me just give really a broad outlook of that. We had a brief conversation when the skinny budget was released, meaning to say it was the budget that they had big numbers but without any details of what's going to be cut. So NASA budget will have about 25% cut. So it will go from about $25 billion to $18.8 billion. But that's the overall NASA. If you look at it more closely for the science missions. And so here we are, like the Chandra X-ray Observatory, for example, would fall under science missions. James Webb Space Telescope and others fall under the science missions. Over there, you have almost a 50% cut, 47% cut from 2025. And if it goes through, some close to about, the estimate is 40 science projects are going to be cut. And that includes, for example, Mars sample return mission that has been in the works. There has been issues with that, but it has been in the works. Several Earth System Observatory program, Mars Odyssey that has been orbiting Mars. There was another mission, Maven mission, that both of those are orbiting Mars. They are going to be decommissioned. There are again future plans to collaborate with others. For example, European Space Agency, there are missions that NASA actually works with. For example, Rosalind Franklin Mars rover mission, that is going to be canned. And then 2 missions to Venus. And for our local connection, we had talked to, we had mentioned sort of a couple of years ago, Professor Darby Dyer.
Yes.
And she just retired from Mount Holyoke, but she's in charge of one of these missions. Well, both of those missions are supposed to get canceled from there. There are spacecrafts, Juno, for example, around Jupiter, that New Horizons, that has passed Pluto. It is going farther out. That is going to get canceled. And Osiris Apex mission. So you remember the mission that brought back samples from an asteroid, and then it came back, dropped the samples, and then it is off to go to visit another asteroid, in fact, Apophis, that is going to be canceled as well. I mean, these are superbly successful missions. These are missions that, again, you talk about what makes NASA. Why are people all around the world wearing NASA shirts or NASA, just an emblem also. Like logo shirts, or a cap and things like that. It's because of the success of missions like these, because they are an incredible feat of creativity, ingenuity, engineering, which you go like, wow, NASA, and that's why it comes in. What? NASA does these things, right? And secondly, it's the type of information we get. Yeah, we get a little bit away from our day-to-day life, and you go like, you know what? Here is a spacecraft that that traveled all the way to an asteroid, landed on top of it, brought the samples back, and then brought in and dropped them on the Earth, and we could go and retrieve them, and then we could look at it, what those samples have. I mean, this is incredible. This is not about your usual politics or your religion or anything. This is just pure about curiosity, and it lifts you a little bit that, hey, at least for a little bit, humans decided that instead of focusing on war and kind of drones and all of that stuff, here we use this technology to try to answer some of our questions about, hey, what are these asteroids made up of? Could they have building blocks of life, which actually turns out a lot of the fundamental blocks of life are in these asteroid samples. So that's what it does. But if you cancel that, and that's one of the reasons, justifications that is given is that we want to focus just on very specific things and a very sort of practical matter, pragmatic matter. And so from that perspective, there is money for human space missions. I think that is still there.
Which is cool, but it does harken back to the early days of the space race, where the Apollo missions were not science missions. They were flexing America's might to show what we could do in space before the Russians were going to do it. Now we're doing the same thing again. We're cutting the actual, the kind of ideals of Star Trek.
Yeah.
And trying to learn more about who we are and what else might be out there to, once again, just get in a race, this time mostly with China.
But I think there is a long-term disadvantage to that. If you stop focusing on things that are purely based on curiosity, on most foundational things. So apart from the fact that, as I mentioned, there is a reason why NASA logo, for example, is a really popular thing all over the world. So there is soft power, if you want to play that game, in terms of that. But also fundamental curiosity, thinking about these things are the things that get people interested in science. You actually get this workforce in NASA or in universities because of the wonder part of it. Space program, yeah, human space program is interesting, but there is a lot more around it. The kind of questions that come around are actually much broader than that. And and even with the human space program, the existing missions like the Lunar Gateway mission and a program around the moon. So this was the program to have a space station around the moon, and space launch system. So this was a sort of like not a SpaceX but a competitor to SpaceX. That has also been canceled after Artemis 3. But there is an parallel new program which is about $864 million have been allocated for, quote, commercial moon to Mars infrastructure and transportation program. And there are others like more than $1 billion on projects associated with human Mars program. So that is there at the expense of this thing. I actually don't know what is going to happen with Musk and Elon Musk and SpaceX, because the NASA's the person to lead NASA was supposed to be Jared Isaacman, who's a close friend of Elon Musk. He was confirmed for the Senate subcommittee, Commerce Committee. That's where NASA's budget comes from, and he was set to be confirmed as NASA head on June 3rd. It was all set, and the committee that confirmed him on the Senate was unanimous. And so it looked like it's going to be a shoo-in, but then just suddenly 2 days ago, his nomination was withdrawn by the president. And it is stated the reason given is the fact that he had donated before to the Democrats. But it's a little weird because apparently there are sources that are saying that he had actually disclosed pretty early on that, yes, he had donated to the Democrats, but he also, by the way, gave $2 million to the Trump transition team. But his nomination has been withdrawn. So however you look at it, that is a big deal, because suddenly somebody who was coming in, and I was a little bit lukewarm about that, because after all, how many billionaires can we fit in through the government? But okay, all right. But what I fear is what is going to be the alternative, and the reason behind pulling his nomination just a few days before he looked like to be a shoo-in to be the NASA head, and the tension between President Trump and Elon Musk. How is it going to manifest? So that's another thing that is happening. But let's close in with more sad news, and that is about the National Science Foundation. So I have mentioned the NASA funding, and as you can see, a lot of the funding goes to astronomy, science thing, and roughly 50% of science missions are going to get sort of like canceled if the budget goes through. By the way, you still have voice. Write to your congressman, write to your senators, write to your members of your Congress, and just ask them not to do this, that there is value to that. But for National Science Foundation, which funds your basic science, there is proposed cut is 56%. So more than half of your National Science Foundation funding is proposed to be cut in the $9 billion budget. So again, you didn't have that much money to begin with, and you are cutting from $9 billion, you're cutting about 56%. And then the way it is being cut is weird. So, for example, one of the things they've suggested to cut is LIGO. This was the Laser Interferometer Gravitational Wave Detector Observatory, which actually was the first one in the world to detect gravitational waves back in 2015, 2016.
Which proved a scientific theory of Einstein's and all of the stuff about the space-time continuum and light, blah, blah, blah. Amazing stuff, but proven with LIGO.
Right, and these were predictions, and there are two of these observatories. One is in Louisiana and one is in Washington State. And actually the science is really cool because these waves travel at the speed of light. That was one of the things to confirm, and they did. And having these two observatories detect the same thing with a slight difference actually tells you, first of all, it confirms the detection, that it's not just a something that happened, sort of like, a truck went by the first one, and these are so sensitive that yes, it can vary, it can impact. But if there is another one that's also detecting at the same time, you can also check the variations of it, sort of like, are those sort of like, what kind of patterns that it is seeing. And also the slight time difference actually can give you a lot of information between the two places, even though, I mean, these are amazingly precise instruments. So in the new budget, one of the LIGO observatories is supposed to be cut.
But the other one, which is there to confirm
Yeah.
the first one,
Right.
okay.
That is correct.
Sounds
and
smart.
This is the observatory that also led to a Nobel Prize on that, because this was one of the most stunning confirmations, and it continues to discover these gravitational waves are produced often by colliding black holes or neutron star mergers. I mean, these are events that are happening sort of like, in the universe, usually quite far away, and it has opened up a whole new universe, no pun intended, of how to study of these objects through these gravitational waves. So it's like you gaining a new, again, we talk about different types of observatories looking in X-rays, radios. Here is another way of looking at gravitational waves, and these are pretty much the only observatories. I mean, there are some other coming up, but right now, these are the leading observatories looking at phenomena, high gravitational interaction phenomena that can be observed only through LIGO. And one of them is slated to be cut. And that's a little strange thing. But then again, you also have, there are chances of cutting the large telescopes. There are 2 large telescopes that were being planning on being built, giant Magellan telescopes. So that may still go. But the 30-meter telescope, which has its own history of controversy because it's on Mauna Kea in Hawaii, but the 30-meter telescope is being canceled. But the other thing is just in general cuts in grants. And so what they expect is that the chance of success right now for an NSF grant is about 1 in 4, about 25%, which is tough. I mean, you have to really write good proposals because you only have 1 in 4 chance to be successful. With the proposed cuts, it's going to get to 7%. So down from 25% because the kind of amount of resources that are going to be available for that. So, and a lot of the grants, about $1 billion to increase diversity in the workforce, that's also going to be cut overall. STEM program from NASA, that is also going to be eliminated.
With all these cuts, and then also the cancellation of international student visas, the United States has ceded its place in the world as a nation that cares about furthering the sciences, it seems.
Right, and as a person of DEI,
You're one of those DEIs.
I'm one of those DEI. I mean, it's scary, and I empathize deeply with international students because I myself was one. I came to the U.S. over 35 years ago, and I came to Stony Brook in New York, on Long Island, and it is, as an undergraduate, I was 19 when I came here, and it is a stressful time. Everything is new, everything is different, and you are on a student visa. You have to, even under normal circumstances, you have to make sure your status is there. You have to have your paperwork right and all of that stuff. And I remember post 9/11 coming from Pakistan, and again, we have also talked about that. A lot of people from Muslim background, they were targeted. And many people don't actually know in terms of what had happened, but all males between the ages of 15 to 45, this was under President Bush in 2003, I think, who were not on green card, but who were sort of like, on H-1B visas, work visas, or on student visas. They had to go and do a special registration at the time newly created Department of Homeland Security, and I was one of them. And it was not the most easiest experience. I was at Smith College at that time as a postdoc, Smith and UMass, but there was a lot of panic associated with that because people were worried about their status and things like that. Now, there are a lot of students being targeted But I see a parallel, and I don't see the same kind of anger, I think, about the Chinese students being targeted. I mean, the reason I wanted to bring in those two experiences of being a foreign student and being targeted from coming from Pakistan and being a male between the ages of 15 and 45 at the time, not anymore. But I think we should, I mean, just imagine the fear that is going through the Chinese students. And if I've looked at the numbers, it's like around over 250,000, 270,000 Chinese students right now are in the US. Your Secretary of State coming in to say, like, that we are going to cancel their visas. We're going to look into it. We're going to cancel their visas if they have any connection to the Communist Party in China, which I don't know what that means. And so far, their record of being right has been actually pretty challenged. Right? Even the robot Biden may have done better regarding that. But just imagine on the personal lives of students who are here, who have left their country. Sometimes they have some relatives or whoever that is here, and sometimes they don't. I mean, you're a first year. You're just finishing up your first year. You're a sophomore student. You are at UMass or you are at other places. I mean, I'm not even talking about graduate students or postdocs that fill up the US labs, science labs, which are going to be impacted by that. I'm talking about these undergraduates who are like 19, 20, 21-year-olds. And you have Secretary of State coming in to say, you know what, you may cancel your visa. And it's unclear how they're going to find out, because that's what's been going on. They cancel the visa and they get an email and they give them 24 hours or 48 hours to actually get out of the country. That, apart from being cruel, is going to have a tremendous impact on U.S. Academia, U.S. science as well. I've had cases, I get emails or questions from Pakistani students, like, who are applying and things like that. And I'll be very honest, in the last couple of months, whenever this question has come up, I seriously ask them, why do you want to come to the US? And I do suggest not to come, because I don't want them to go through the same type of thing that other people are going through. And to me, that brings back to this thing that it's sad. I mean, we're talking about killing curiosity by killing science, but we are also killing off why people came to the US. And that was not just the wonder of science, which for a lot of people it was for me, but also that it's an open society, that you don't feel threatened randomly, which can happen at other places. Not that US was a perfect country. I mean, I want to be clear about that. I mean, especially treatment of African Americans and others historically and today too. But I'm just saying that even that last bit of sort of like, angle that people would think that, well, this is why I would go to the US, because I can express my views, I can be there, and I can get educated. And there will be a system that once you are in there, because the system works, that you can actually go through the education and you have the ability to go into a postdoc or academia and so on and so forth, which I did. I benefited from it. Today, that doesn't exist. And I don't think if somebody is coming in, realistically, they should look at it. US would not be the place to come.
That's it. I don't want it to end super depressing, so I'm going to say, well, on the positive side of things, you might be able to see the northern lights through your iPhone tonight.
Yeah. Well, and on the positive side, there is light out there, and that is coming from the north.